So why do we need? First of all, the question is why do we need, right? Why did Google go through all the trouble to build something as sophisticated as Zanzibar? Let's break it down. Flexible modeling approach. Google's range of products is incredibly diverse, each with unique permission requirements. Drive has its settings. YouTube handles video access control. Google Cloud uses role-based access control. Map relies on attribute-based access. Okay, I don't know what it is, but okay. Google needed a system that could handle all these varied needs smoothly. Okay, so flexibility. Zanzibar is like a Swiss Army knife for access control. Support wide range of access control policies catering to both customer and enterprise applications. This flexibility allows Google to define and extend different access control methods within one unified system, making it easier for applications to work together and manage permission efficiently. High availability and low latency. Imagine if every time you try to access Google service, you have to wait forever for it to check your permission. Frustrating, right? Google wanted to avoid that. High availability and low latency. Zanzibar ensure that services are always up and running. If the system couldn't reliably check permissions, service might have to deny access, leading to a poor user experience. Zanzibar makes sure it doesn't happen. Low latency, speed is crucial. Authorization checks are often in the critical path of user interactions. Zanzibar make these checks lightning fast, even during peak times. This is essential, especially important for things like search results, where hundreds of checks might be needed in a split second. Handling large scale. Google services are used by billions of people worldwide. Managing permission for all these users and their data is no small feat. Zanzibar is built to handle billions of objects and usages deployed globally to be near its client and then their end users, ensure efficient and scalable authorizations. It is having massive, well-organized library where you can quickly find exactly what you need, no matter how many books are there. Consistent and secure access control. Keep everything consistent and secure is a top priority for Google. They need a system that could ensure this all across their services, correctness and security. Then you want to make sure the access control decisions are consistent and respectful. User intention, this means you won't accidentally get access to something you should not. By centralizing and standardizing authorization checks, you are enhance security across Google's services. Okay, so basically they have some centralized mechanism from where they can control their security across all the Google services, right? Otherwise, each every service will have different type of security. So it suppose complex policies maintain strict. Um, okay, how Zanzibar authorization works? Let's dive into nuts and bolts of how Zanzibar operates. By understanding its workflow, you will see how the system efficiently manage access access control. Google's vast varieties of services. Okay, How sensible authorization? First of all, modeling. We discussed about modeling, right? How actually they store their models that help us to identify the relationship. So there are some relation tuples which are simple statements. Which are simple statement that define relationship between user and object. These tuples look like X. User X has a relationship Y, relation Y to object Z. For instance, user one owns document two, so is represented as document two, and owner is user one. Okay, so this is how they define document sharing. If user one creates document two and allow user three to view it, so how the relationship double will be look like? So basically, to user one creates a document, so he is the owner, right? So document two hash owner and at the rate user one, right? So and if we want to view, so for viewing, this is the relation, right? Also, one more thing, if you are the owner, then you are already have the viewing capability, right? Correct. These tuples are stored in centralized database, making it easier to look up permission quickly. Okay, but how they are fetching, that we have to see. Storage, they will store these relationship tuple in Google Spanner. Okay, that is a different, Google Spanner, a globally distributed database system. Spanner ensures that all data is consistent, replicated across multiple locations. This replication is crucial for maintaining high availability and low latency. So Google Spanner, if we search this, okay, so there I have some Google Spanner, which is globally distributed database. Okay, we don't need to dive into it, but Sensiva that actually store these relations tuple in a spanner. Spanner ensure that it is consistent and replicated across multiple locations. This replication is crucial, maintaining high availability and low latency. High availability because we are replicating, and how we are actually achieving the low latency we don't know, but yeah, somehow they have written it. Replication. If we talk about the replication, data is stored multiple locations, one way to ensure fast access, reliability, and consistency. So span true time mechanism ensure that all the data changes are globally consistent, meaning that authorization data are based on the most up to date information. Okay, so they have something called spanners true time mechanism that actually ensure that all the data are globally consistent. Okay, we might have to deep dive into spanner. Okay, true time is a distributed clock system that provides global and highly available times. So available time sources the bomb means it use combinations of GPS receiver, atomic clocks in data center to generate timestamp. Okay, so it is a so it is actually a distributed clock. Like vector clock, we have red, and they're using some kind of true time. We might have to go into this later, but I just want to write it down somewhere. So we are right here reading Zanzibar, right? So Zanzibar. Okay. First of all, let's copy this. I'll just paste in my OneNote so that we remember. I mean, we can read it later, right? So that's the whole idea. So, okay. Next thing, what we have in the Zanzibar. So storage we have understand they are using span and for high availability, it is replicated in multiple instances on different locations. Also, consistency they are also maintaining the consistency using spanner two time mechanism. Okay. Now API request. So the Zanzibar provides several APIs that allow application to interact with the system. These APIs enable reading and writing of relation tuples, checking permission, monitoring changes. API like read, write, watch, monitor changes in the stored relation tuples, check, verify if user has the necessary permission to access an object. Okay. Understand all permissions related to an object by expanding the relationship. Understand all permissions related to an object by expanding the relationship. Okay. Checking access to ensure if user 3 can view document. Okay. For example, if to check if user can view document 2, the application would use check, correct? We need to use check. We need to see like can view the document or not. Then you will look up the relevant tuples and confirm that document to viewer user 3 exist and granting access. If this relation exists in the database, then they are just saying that okay, this guy has the access. Now, this we have talked about EPS, we have talked about storage, we have talked about modeling. Okay, we have talked about modeling as well, talked about storage, API. Now let's talk about centralizing authorization. The centralized authorization Zanzibar provide a consistent secure way to manage permission across Google service. This centralization simplifies the process of defining and enforcing access control policies, making it easier to maintain security and consistent workflow. So define relations. Okay. Application define relationship using relation tuple. These tuples are stored in spanner, ensuring global consistency and availability. Application interact with Zanzibar using the provided APIs to read and write, check, monitor permission. Authorization is when a user tries to access a service, Zanzibar quickly checks the relevant tuples to make authorization decision. How many times application uses right access? Okay, we know this workflow, right? So let's go to the architecture of Zanzibar. To understand how Zanzibar operates, it is most important to understand three uh, main entities: the data model, the configuration language, and the APIs. These components work together to provide a robust, flexible, and scalable authorization system. Let's go to the data model. At the core of Zanzibar is the data model, which uses relational tuples to represent the permission. A relation tuple simple statement. Oh my god, he is repeating again. These tuples are used, we know. Configuration language. Zanzibar configuration language allows developer to define complex access control policies. This language uses set of keyword and concept to create flexible and detailed permission settings. Key concept configuration language. Okay, this is how you model your tuple. So namespace define the scope of object and their relations. Specify the type of access and a role a user has. Owner, editor, viewer. Okay. Relation is like oh, you are the owner, you are the writer, you are the maybe reader, right? Like viewing, right? So user set read write rules allows allows defining complex relations by combining basic relations. Okay, I don't know what it is. User set read write rules allows defining complex relations by combining basic relations. Okay, we will see it later. So, for example, if we have a name document, relation, owner, editor, union, child, this computed user set. viewer, union, child. I don't know what it is. Explanation. In this configuration, all owners are also editor. So if you see the owner, it is an editor. Okay. And all editors are viewers. Union child. This I don't know where is the viewer. Okay, this is the viewer. Union child. This computer user set. A relation is complete. Okay, Zanzibar provides some APIs which we, I think, already know. Implementation of Zanzibar. Implementation of Zanzibar involves several high-level steps to ensure that it is scalable, consistent, efficient. While we won't dive into actual coding here, I will provide an overview of what it takes to build a system like this. For a more detailed example, check out our blog post exploring Zanzibar demonstrated with basic. Defining the user relationship tuple to represent permission. Ensure that each tuple clearly defines the relationship between user and object. Store these tuples in centralized, globally distributed database like Google Spanner to ensure consistency and availability. Develop the configuration language. Create a flexible configuration language to define access control policies, support complex operations like union, intersections, exclusions to cater to various access control needs. Why do we need union? I just want to understand. Allow the configuration language to enter union group member and other enhanced permission scenarios. Implement APIs for reading so that use snapshot read to maintain consistency across distributed data. How? How snapshot read in the snapshot read state of all the specific variables ensure that all the authorization checks are made. Snapshot read capture the current state of specific. In Permify, you can define that user has certain permission because of the relation to other entity. An example would be granting a manager the same permission as their subordinate or giving a user access to a resource because they belong to a certain group. This is facilitated by a relationship-based control which allow the definition of complex permission structure based on relationship. Okay, so let's read about this schema. So level the command operation of the language allows you to define arbitral relations between user and object such as the one you can define even is this guy will be well, defining entity. This is the first step to build a permify schema is creating your entity. Entity is an object that defines your resources that have role in your permission system. Think of entity as a table in your database. We are strongly advised to name entities same as your database table that its corresponds. Okay, and that way you can easily model and reason your authorization as well as eliminating the error possibilities. Okay, you can create entities using entity keyword. Let's create some entities. According to our example, determine operation logic, user relation, team, and repository. So, what are the different entities we need in the GitHub? So, user, correct. User should belong. Say he belongs to an organization. Organization will have many different groups. I don't know. And each group will have some users. And there is a repository which can be accessed by a particular user or group, right? Uh, yeah, correct. So user group is actually a team here, right? So entities has two different attributes. These are relations or permissions. Okay, a relations actually defines the relation. Right? Permission is something that you can do some operations. You know, so that kind of information permission defines. And defining relations. Relation represents the relationship between entities. It is probably the most critical part of the scheme because permissions are mostly based on relations between the resource and their permissions. Okay, who is the resource? Repository ka we need to give the access to the repositories. The relations represent the relationship between entities. Okay, so we need to use relations keyword to create a entity relation to create a entity relation with a name and tribe attribute. I think this should be okay. Let me drink some water. So we need to define the relations, right? So relation represents relationship between entities. It is probably the most critical part of the schema because Okay, so we know that there is a keyword called relation. Okay, name of the relation and type. Basically, the entity is related to. Okay, let's turn back to our example. So we have a user entity, right? The user entity is a mandatory entity in Permify. It generally will be empty, but it will use a lot in other entities in relation. Okay, roles and user. You can define user type and roles within the entity. If you specifically want to define a global role such as admin, we advise defining it at the entity with the most global hierarchy such as organization. These are administrator and direct member of the group, organization, relation, name of the relation, that is an entity. Okay, so basically this admin belong to type. What type of relation is this? Organization will have some relation, admin relation with the user. Okay, let's say team can belong. Organization can have a member inside of it as follows. Team can belong. Team parent is organization. Okay, relation member.